Hi ladies, in this video we're going to go through the theory for 60, index laws 4 and 5. I'll just make that a little bit bigger. So you can see here in the key ideas, we've got index law 4. So this law basically says when you have, I shouldn't say multiple bases, but when you've got a bracket and there's more than one base, so we've got an A and a B, to a power, everything in that bracket is taken to that power. So you can see A times B we usually write as AB. So the A is taken to the power of M and B is taken to the power of M. And you can have a number in here, so it could be a 2. The 2 is also taken to the power of M. So you can see here, here's an example. Here's something I prepared earlier. 2x to the power of 2, so the 2 is taken to the power of 2, and the x is taken to the power of 2, so you get 2 squared, which is 4x squared. Index law number 5 is when inside your brackets you've got a fraction or a division, so your numerator and your denominator are both taken to the power of m, and this is just saying where b is not equal to 0, because if the denominator, so the number on the bottom, was 0, the fraction would be undefined. So here is an example here of y over 3 to the power of 3. So the y is taken to the power of 3 and the 3 is taken to the power of 3, so we're left with y to the power of 3 over 27. Okay, so question 2. I just ate some almonds, so if I sound a bit weird, it's because I've still got almonds in my mouth. Okay, so let's start off with an easy one. So 5y to the power of 2, and I've mixed up my colours here. So we take the 5 to the power of 2 and y to the power of 2, and we can actually simplify this. So 5 to the power of 2 is 25, and then y squared. All right, let's try a harder one. So J looks interesting. So we've got 8t squared, u to the power of 9, v to the power of 4, and that's, actually, it's not as complicated as I thought. So remember, in the previous chapter, anything to the power of 0 will be 1. So everything in here is taken to the power of 0. So it's just equal to 1. All right, and let's do k, which is a negative. All right, so we've got k, which is negative 4, p to the power of 4, qr to the power of 2. So anything outside the bracket is not actually taken to that power. So the negative 4 just stays negative 4. And then p to the power of 4 times 2. Then q to the power of 2 and r to the power of 2. Okay, so let's just simplify that. So we've got negative 4, p to the power of 8, and then we've got q to the power of 2 and r to the power of 2. All right, maybe we'll just do L as well. So negative 5s7t all to the power of 2. Now, remember, if we get a negative number, it's a good idea just to put it in brackets so we remember that negative, and that's a 5, because then we've got an s. 7 times 2, and then t to the power of 2. Negative 5 squared, you're going to get positive 25, because a negative times a negative gives you a positive number. Then we have s to the power of 14 and t to the power of 2. Okay, let's move on to question 3. So I'm going to get rid of all that. All right, I'm going to let's start with G. Okay, and I'm just choosing these at random. I don't want to always do the easier one. That's why I thought, let's start with G. Okay, so the numerator and the denominator are all taken to the power of 3. So we're going to have 3n, and if it's easier to write it like this, so you don't forget to do everything inside that bracket, you can. Okay, so the numerator and the denominator are taken to the power of 3. So 3 to the power of 3, and then n, 3 times 3 gives you 9. Then on your denominator, you've got 2 to the power of 3, m to the power of 4 times 3, which is 12. And let's just simplify that. So we've got 3 to the power of 3, which is 27. So 3 times 3 times 3. And then 2 to the power of 3 is 8. So 2 times 2 times 2. And we can't simplify that any further because 27 and 8 don't have any common factors. All right, let's do another complicated one. So let's do k. So we've got, my initials again. KM, thrown in an N, not a part of my initials. Okay, so again, if you want to, you can rewrite it. Oops, don't forget that cubed. With your numerator and your denominator in brackets. So we remember to take everything inside to the power. So we've got 3 to the power of 3, k to the power of 3, then m, 3 times 3 gives us 9. And then on our denominator, we've got 7 to the power of 3, and 7 times 3, which is 21. So let's just write 21 because we did that for the numerator. Okay, so let's just, where's my thing? 3 to the power of 3 is 27, k cubed, m 9, 7 to the power of 3, so I can't actually do that in my head, so 7 times 7 is 49, 49 times 7, okay, 343, I think. Might just have to, what am I doing? N to the power of 21. I might just check that on my calculator. Okay, so 7 times 7 times 7, beautiful, 343. Okay, let's move on to, let's have a look at question 4. So this one here, we've got to apply a variety of index laws. So remembering the other index laws when doing this question. So I'm going to do E just because I can see there's a negative number there. But you can hear the young girls outside playing. Just make sure I've written it down correctly. So everything is taken to the power of 3. Now if you get a negative, just put it in brackets. Then we've got 2 times 3, which is 6. C to the power of 5 times 3 is 15. And then D to the power of 1 times 3, which is 3. Negative 4 to the power of 3, so it stays a negative because it's an odd power. So negative 4, forget about that negative. It's probably 4 times 4 is 16. Times 4 again gives you 64. B 6, C 15, D 3. Okay, let's do another one. Maybe let's do L. Negative 4a squared b cubed negative 2a3b squared squared. Okay, so everything in front of that bracket just stays the same at this point, and that's still with everything inside this bracket. So we've got a negative 2 there. I'm going to put that in brackets. A 3 times 2 is 6, and then b 2 times 2 gives you 4. So I've got negative 4a squared b cubed. Now negative 2 is taken to an even power. So it's going to be 2 squared, which is 4. a6 b4. Now let's bring everything together. So I've got negative 4 and a 4. So negative 4 times 4 gives me negative 16. Then a, we've got 2 plus 6. So remember that when you're just multiplying, you add your powers. So 2 plus 6 gives you 8. And then b to the power of 3 plus 4, which is 7. All right, question 5, you're using a range of index laws again. I might just do one from here. Now, questions like this, just require you to have a knowledge of your index laws. They can add in as many numbers and letters as they like. I don't think it really complicates things. It just means hard work. You know, it's kind of like doing the dishes, and if you just had one person eating, it's only a few dishes, but you had a whole family, you're going to have a lot of dishes. So here, you know, it's the same work, it's just more of it. So the -5 stays out the front. Everything inside is to the power of 2. So we're going to have 3 to the power of 5 times 2, which is 10. Whoops, what did I do that for? I was actually thinking of the bracket that I did here and whether I should do that. I had brackets on my mind. Okay, so m 3 times 2 is 6, and then n to the power of 4. Then on our base, we've got -3. Now, I'm not going to do -3 to the power of 3 just yet because I can see this 3 here. Things are going to cancel out. So we've got 3 times 3 gives us 9. M to the power of 2 times 3, which is 6. And then n to the power of 1 times 3, which is 3. Okay, so what I was thinking before is this bracket doesn't need to be there because we're multiplying. So if you want, you can put a multiply in there so we don't see it as -53. Now this 3 to the power of 10 and this -3 to the power of 9, you've got a different base here. Okay, so you've got a +3 and a -3, but you've actually got a negative here. So you can get rid of those two negatives. Okay, so that's a negative divided by a negative, so they cancel out. And then we've got 3 to the power of 10 divided by 3 to the power of 9, so that cancels out with one of them. So that just becomes 3 to the power of 1. These m to the power of 6's cancel out, and this n to the power of 3 cancels out with that 4. Now, I probably should have done that with a different color, but we're now left with 5 times 3 and nothing on our denominator. Just make, and this n here. So our final answer is 15n. Okay, let's do one more from question 5. Whoops. Trying to delete that. I was pressing Shift A, not Control A. All right, let's do 5L. So I think that's an R. R3S over T divided by S. Now is that RT4? And that's all to the power of 3. And I forgot the 2 here. Okay, so remember everything on your numerator and your denominator is taken to that power of 2. So let's do that all in one go. So 3 times 2 gives you 6. S to the power of 2, then T to the power of 2 divided by, and that is an S, just double checking that it's not me not writing 5 correctly. R to the power of 3, T to the power of 12. Now, when you're dividing a fraction, we keep change flip. So we keep the first fraction as it is. I can't actually simplify that at the moment. We change our division sign to a multiply and we flip our second fraction. All right, so you can, if you want, bring everything and put them in the same denominator and numerator, but I'm going to do my cancelling here. So this, did I just make sure that S is correct? Okay. So this is actually looking at a different index law. So this actually cancels out and makes that a 1. Okay, so not a negative 1, and that's an index law that you're not going to be exposed to just yet. So we'll just keep that as, so the 2 can cancel out with that, but that leaves that still as a 1. T squared can cancel out with that. So we're left with, T to the power of 10. And then we've got the R's stay on the top. So our final answer is going to be R to the power of 9. So we're multiplying our powers, adding our powers. And then on the bottom, we've got S. and the and the t. Sorry, missed the t over here. T to the power of 10. All right. Bye, girls.